Hello everyone, I am Geeta, Assistant Professor, Department of Mathematics, SNS College of Engineering. In this session, we are going to discuss about randomized block design and latent square design. Randomized block design is one of the experimental design. It is used to control the effects of known sources of variability among the experimental units. It controls variation among blocks. Here the treatments are assigned randomly in each block. Now I am going to explain what are the procedure for analyzing the data in randomized block design. First we frame H1, that is null hypothesis. That is, there is no significant difference between rows and column. After that we frame alternative hypothesis H1, that it means there is a significant difference between rows and column. After that, first we find n is nothing but number of observation. After that we find t value. T is nothing but total of observation. Next we find the correction factor value, that is t square by n, and next calculate TSS. TSS is nothing but total sum of squares. That is calculated by the formula summation x1 square plus summation x2 square etc. minus t square by n. So next we are supposed to find the SSC. SSC is nothing but sum of squares between column, which will be calculated by the formula summation x1 square, x1 the whole square divided by n1 plus summation x2 the whole square divided by n1 etc. minus t square by n. Here n1 is nothing but number of elements in each column. After that we are supposed to find SSR. That means sum of squares between row, which is calculated by the formula summation y1 the whole square divided by n2 plus summation y2 the whole square divided by n2 etc. minus t square by n. Here n2 is nothing but number of elements in each row. So after that we are supposed to find SSC, that is nothing but error value which is equal to TSS minus SSC minus SSR. After that we frame ANOVA table. In ANOVA table, first we write source of variation, after that sum of square, next degrees of freedom, then mean square value, after that variation ratio. Here in sources of variation we write between column and between row and error. In between column sum of square is SSC, between row sum of square is SSR, in between in error sum of square is take it as SSC. After substituting this value we calculate the corresponding degrees of freedom. In SSC it is column minus 1, in SSR it is row minus 1, in SSE n minus c minus r plus 1. After finding the degrees of freedom, next we move into the mean square value. Mean square value is nothing but MSC, which will be calculated by SSC divided by c minus 1. SSR divided by r minus 1 is MSR. SSC divided by n minus c minus r plus 1 is nothing but MSC value. After finding MSC, MSR, MSC value, we have to calculate variation ratio. So FSC equal to MSC divided by MSC or MSC divided by MSC. So numerator must be greater than the denominator. Based on this concept, we have to calculate FC value and the FR value. Next, F ratio in row wise is equal to MSR divided by MSC here. After finding the after finding the calculated value, we are supposed to find the next table value. So using F ratio table, we are supposed to find table value. After that, our conclusion is, if the calculated value is less than the table value means we accept that H0. If calculated value is greater than the table value means we reject the H0. We discussed about latent square design. It is also one of the experimental design used to control the effect of known sources of variability among the experimental units. Here That means there is a significant difference between rows, column and treatments. First, here also first we find n, that is number of observation. Next we find t, that is total of observation. Next correction factor t square by n. After that total sum of square, and next SSC, that means sum of square between column. After that we move into SSR, that means sum of square between row. Next we are supposed to find the sum of square between treatment also. After that here we find the error value equal to total sum of square minus SSC minus SSR minus SSC. Here we are in randomized block design. SSC formula is TSS minus SSC minus SSR only. Here we are considering only column and row. Here we are considering treatment also. After that, the same procedure for ANOVA, source of variation we calculate between column, between row, and again we calculate between treatment also. Right? After that, we find the error value. Its sum of square is take it as SSC, SSR, SST, and SSC, and the corresponding degrees of freedom. One more thing here I am going to point out. In Latin square design, number of rows is equal to number of columns and is equal to number of treatments. Both are same. Then only we move into the Latin square design. So here we are having number of row equal to number of column and equal to number of treatment. So here the degrees of freedom is k minus 1, k minus 1, k minus 1, and in error calculation we are taking it as k minus 1 into k minus 2. After that we move into the mean square value. It is calculated by MSC, that is equal to SSC by k minus 1, and SSR by k minus 1 we take it as MSR, SST by k minus 1 we take it as MST, SSC divided by k minus 1 into k minus 2 is take it as MSC. After that we find the F ratio value. So MSC by MSC, MSR by MSC, and MST by MSC. Here one point is noted here. Numerator must be greater than the denominator. Next we are supposed to find the table value. After that, coming to the conclusion, the calculated value is less than table value means we accept the H0, otherwise we reject the H0 here. Thank you.